The night sky isn't what you think it is. It's not the beginning of time, it's a graveyard of light. The James Webb Space Telescope just sent back images of thermal bruises in deep space, physical scars left behind by a universe that died before ours was even born. The data doesn't just tweak the laws of physics, it sets them on fire. And NASA is panicking. University of Kansas astronomer Alison Kirkpatrick couldn't sleep. She had spent her professional career studying how galaxies grow and evolve. But the first images from the James Webb Space Telescope, or JWST, left her questioning everything that she thought she knew. JWST is the most advanced and powerful space telescope ever built. It was going to give astronomers and scientists a glimpse into the past, a hint about how the first galaxies formed. Instead, it showed bright, fully formed galaxies where there should have been darkness. They appeared in regions of the universe that should have been practically empty. Back then, the cosmos was supposed to be a thin fog of hydrogen and helium, slowly cooling and drifting, waiting for gravity to do its work. But these images, they didn't make sense. The primordial fog was expected to last for hundreds of millions of years, just floating in space, long before any stars were born. And those first celestial bodies should have burned out quickly and scattered the ingredients for everything that followed. So the universe in theory should have been a blank canvas. JWST said differently. The common assumption was that the universe followed one model, Lambda-CDM. It's the standard story of the cosmos: a hot Big Bang, invisible dark matter pulling gas into clumps, and dark energy driving everything apart faster and faster. For years, the data backed it up. The universe was 13.8 billion years old, or so we thought. The first full-color Webb image landed in 2022, showing a galaxy cluster called SMACS 0723. Immediately, something was wrong. There were too many galaxies. They were too bright. They shouldn't have been there. Research papers were thrown out, consigned to the trash cans. If the images were accurate, then the timeline of the early galaxies was wrong. The old galaxy consensus was dead. A faint smudge in the Boötes constellation was the prime suspect. Its catalog name is CEERS 93316, and its first measurement suggested it was seen at a redshift of 16.7. That was a number that raised eyebrows. Redshift is essentially a time machine built into the fabric of the universe. As space expands, it stretches the light traveling through it, pulling it toward the red end of the spectrum. The more stretched that light is, the further back in time it comes from. Eventually, looking deeper into redshift feels less like looking farther away and more like watching earlier and earlier versions of the universe play out in reverse. At a redshift of 16.7, the object would sit about 235 million years after the Big Bang. It's in an era where almost nothing this large should have had time to form. Think of the entire universe as a huge building site. A crew has just broken ground on an empty lot. 5 minutes later, you take a photo, and in the middle of the lot is a finished 100-story tower. The lights are on, and there's a hive of activity. There hasn't been enough time to build something like this, and yet, there it is. In JWST's near-infrared images, the galaxy looked exactly like that kind of anomaly. For a moment, it fit the profile of something from the early universe, and then that argument began to fall apart. That 16.7 was a quick estimate, pulled from the galaxy's color across a handful of broad filters. It was more like a first guess than just a verdict. So the team went back and ran through JWST's spectrograph, an instrument that reads light in detail. The result changed everything. The extreme distance disappeared. The true redshift was 4.9, an ordinary galaxy about 1.2 billion years old. What had looked like a cosmic record breaker turned out to be a trick of alignment. At just the right distance, a hydrogen emission line slid neatly into 3 of the reddest filters, while a set of oxygen lines boosted a 4. It lit up a handful of bands, it went dark in the rest, and it mimicked something far older than it really was. The most distant object ever seen was a mirage. But not every galaxy collapsed under closer scrutiny. Some held up completely. By 2024, dozens of early galaxies had been checked, and most were where their first color estimates suggested. Only a few, like the Boötes smudge, turned out to be imposters. The real early galaxies tend to be smaller and dimmer, but they survived every test. So the early universe isn't an illusion, it's just harder to read than it first appears. But one problem still refuses to go away, and it is worse than anyone thought. Adam Rees, a Nobel Prize winner, studies how fast the universe is expanding right now. His team builds what's called a cosmic distance ladder. It's a way of measuring across space using known repeating cosmic signals as stepping stones. And it's caused a problem scientists now call Hubble Tension. Rees and his team used their model and arrived at a number, 73. But there's another way to read the universe. Instead of looking at nearby space, it starts with the oldest light we can see, a faint afterglow from when the universe was just 380,000 years old. It's a frozen snapshot of the early cosmos, before stars and galaxies existed. If you take that starting point and you run the universe forward using the standard model, you don't get 73, you get about 67. Those two numbers should match, but they don't. The gap between them has now reached what scientists call 5 sigma. It's a way of saying the difference is so large that if nothing is wrong, it would almost never appear by chance. In practical terms, it's about 1 in 3.5 million. That's almost 3 times rarer than getting struck by lightning. At first, people assumed that it had to be an error in the cosmic ladder, but JWST looked again. There was no error. Rice had used JWST to recheck over 1,000 of his stars. The distances barely moved. His ladder held. Not everyone agrees on where the problem lies. Wendy Friedman, an astronomer at the University of Chicago, approached the question using a completely different method. Instead of relying on the same cosmic distance ladder, she used a special class of red giant stars as guides. Her results came in at around 70, right between the two competing answers. That matters because it suggests the Hubble tension might not be as simple as one side being right and the other wrong. The trouble is that no explanation has managed to satisfy everyone. One of the leading ideas is something called early dark energy, a brief burst of extra energy that may have altered the universe's expansion shortly after the Big Bang. If something like that happened, it could help explain the conflicting measurements. Projects such as the Dark Energy Spectroscopic Instrument, or DESI, is surveying tens of millions of galaxies, searching for evidence that the universe once expanded differently than we think. Maybe one set of measurements still contains a hidden flaw. Maybe dark energy has changed over time, or maybe the standard model of the universe is missing a piece entirely. What makes the Hubble tension so unsettling is that it goes beyond the usual explanation. Earlier anomalies often faded under a closer look. A galaxy that seemed distant turned out to be closer. A strange signal turned out to be misleading. The mystery shrunk. This one didn't. It's a difference between the universes we see today and the universe our best model predicts. The more precisely anyone measures it, the harder that difference becomes to explain. In 2023, Ivo Labe and his team published a paper highlighting 6 objects that shouldn't have existed. We are seeing them 500 to 700 million years after the Big Bang, when the universe was still in its infancy, yet they already look like fully grown galaxies. The problem was their size. By some estimates, they had 10 to 100 times more mass than models said was possible. A few appeared to rival 100 billion suns, all packed into regions smaller than the Milky Way. If those first measurements were right, astronomers had a serious problem. There simply hadn't been enough time for these galaxies to build that many stars. The numbers didn't add up. So the investigation started over, and as better data came in, the impossible began to shrink. Astronomers called them little red dots. JWST wasn't finding just 1 or 2, it was spotting them everywhere it looked. When researchers studied their light more closely, they noticed something strange. Instead of the clean signature you would expect from a normal galaxy, the light showed wide, smeared emission lines. It was a telltale sign that gas was whipping around a black hole at incredible speeds. And that changed everything. A lot of these objects seemed to hide black holes weighing millions or even hundreds of millions of suns behind their thick clouds of dust. That's important. Black holes can be unbelievably bright enough to fool us into thinking we're seeing far more stars than are really there. One of the earliest candidates looked almost as big as the Milky Way. Our galaxy took more than 13 billion years to build up that much mass. This object seems to have done it in just a few 100 million years. That's what made astronomers wonder if they were looking at something else entirely. One possibility is something called a black hole star, a black hole buried inside a thick cocoon of gas. From billions of light years away, it could look like just a single enormous star. If they exist, JWST might have just found the first one. But there is still a problem. The early universe didn't have that much material to work with. Most of the ordinary matter was still floating around as gas, not locked up in stars. To get that massive so quickly, these galaxies would have to have pulled off something never seen before. Almost every bit of available gas would need to become stars. Then it would have to squeeze it into one small space. It seemed impossible. But there was another issue. Some of these little red dots are surprisingly faint in X-rays. Active black holes usually shine brightly in X-rays. It just added to the mystery. Some of the little red dots could be dust-shrouded black holes. Some could be something else completely. But that idea that these were massive galaxies was fading fast. It's more like the astronomers were counting the wrong light. But what if the galaxies aren't the problem? Physicist Rajendra Gupta proposed a much more radical answer. Maybe those galaxies only look old because the universe itself is older than we think. His model, called CCC plus TL, moves the age of the universe from 13.8 billion years to roughly 26.7 billion. That would give the cosmos almost twice as much time to build galaxies, stars, and black holes. And suddenly those galaxies don't look so impossible. To get there, Gupta combined two controversial ideas. The first allowed some of nature's fundamental constants to slowly change over time. The second updates a theory called tired light. This is where photons gradually lose energy as they travel across the universe. Distant galaxies look redder not because space expanded, but because their light faded during the journey. It sounds plausible, but most physicists aren't convinced. Gupta published the idea in a peer-reviewed journal in 2023, and other researchers quickly responded. Their argument was simple. The model clashes with too much existing evidence. It struggles to address the cosmic microwave background, the leftover glow of the Big Bang. There's a bigger issue. The trouble is that the tired light has been around for a long time, and every time astronomers have put it to the test, it comes up short. If the universe is expanding, distant galaxies should look redder, dimmer, and stretched in specific ways. That's exactly what we see. Tired light can explain the reddening, but it doesn't explain the rest. So while it's a good attempt to solve the mystery, most astronomers don't think it's the answer. But what if the issue was the Big Bang? If anyone gets to propose a radical idea about the universe, it is Roger Penrose. He is one of the world's leading experts on black holes and won a Nobel Prize for his work. His idea is called Conformal Cyclic Cosmology, or CCC. And it starts with a simple question: what if the Big Bang wasn't the beginning? According to Penrose, the universe goes through endless cycles. One age ends, another begins. It's a cycle that goes on and on. Imagine fast-forwarding trillions upon trillions of years into the future. Every star has burned out and matter has decayed. Even the last black holes have evaporated away. Everything is gone. Penrose argues that at this point, the difference between infinitely large and infinitely small starts to lose its meaning, and if that is true, the end of one universe could become the beginning of the next. In other words, the Big Bang might not have been the beginning at all. It could have been the end of a universe that existed before ours. Penrose has gone a step further. He proposed a hypothetical dark matter particle called an Erebon. If these particles exist, they could leave faint traces in the sky that future telescopes might be able to spot. But there's a catch. For this to work, the future of the universe has to behave in ways that we've never observed. That's why most cosmologists see CCC as an interesting possibility rather than a definitive explanation. It's a bold idea. The question is whether nature agrees. Penrose claims his theory can be tested. He believes his cyclic universe left real evidence and we've already captured it. According to his theory, the universe before ours contained enormous black holes. Over time, those black holes evaporated away. In Penrose's model, the final burst of energy from each one crossed the boundary between cosmic cycles and left an imprint on our universe, a fingerprint of a dead universe. Where would you look for that fingerprint? In the oldest light we can see, the cosmic microwave background. It's the faint afterglow of the Big Bang that fills the entire sky. Penrose and his team argue that some regions are warmer than they should be. Not random specks, but circular patches roughly 8 times wider than the full moon. In a 2020 paper, the team reported finding these circles in data from both the Planck and WMAP satellites, and they called them Hawking points. And if their interpretation is correct, these aren't just random features, they're relics from giant black holes that existed before our universe was born. Other researchers examined the same maps and reached a different conclusion. When they reran the analysis, the signal became much less impressive. The problem is that if you search a huge dataset for unusual patterns, you will almost always find some. Think about spotting shapes in clouds. If you start looking for circles, after a while it's easy to find them. So, are these real scars from a universe before ours, or just patterns hiding in the noise? Either way, it sets the stage for an academic civil war. Researchers are working toward one of the biggest questions in science: how the universe began. Careers, grants, and scientific reputations all hinge on getting that answer right. The stakes feel personal because they are. And right now, that search is playing out in real time. In journals and at conferences, teams are arguing over JWST's earliest galaxy candidates, whether they really are as massive and distant as they first appear, or whether effects like cosmic debris are making them look more extreme than they truly are. But this isn't just about distant galaxies, it's also about our place in it. Look at your hands. Every atom in them was forged inside ancient stars. In some versions of cyclic cosmology, even the light around you might not be new in a cosmic sense, it's just recycled from an earlier universe. So where does that actually leave us? Not with a broken Big Bang. The basic story surrounding it still holds. The universe is expanding, and if you run the clock backward, everything points to a hot, dense beginning. It's written into the simplest elements in space. Hydrogen and helium still appear in exactly the amounts the theory predicts. When everything is added up, the age of the universe is still around 13.8 billion years. New surveys are already pushing deeper into the early universe, and those little red dots might change how we think galaxies first formed. Whatever JWST finds, this isn't a crisis in cosmology, but a picture of the universe that is still being filled in one piece at a time. It looks like the James Webb Space Telescope has just uncovered another mystery, and it's not the only one hiding out there. If you want to go deeper, watch 50 surprising facts about space you didn't know to see what else the universe is keeping from us, or click on this video.